You guys did okay, so you can compare your answers to this. We're combining like terms, and looks from here that this fell over here, oops, and this fell over here is our like terms. So I'm going to put them next to each other. All right, and so we have 12ab4, and then do I have any other like terms? Well, this guy definitely is not like term as anybody. But those two that I haven't circled, those two are like terms. So I'm going to put them side to side here. Let's combine. So I can combine these two. And that says 12 minus 21. So I know it's going to be, remember, we don't do anything with the variables. We just add or subtract the coefficients. And that's going to give me negative 9. Minus 9ab cubed, which has no like terms. And then these two, I can combine. So it's going to be something a, and negative 45 minus 15 is negative 60. And that's it. Bottom one, use its trinity property. So we're multiplying this times this, this times this, and this times that. We're multiplying. So negative times a negative is a positive. 4/5 times 35. 35 divided by 5 is 7 times 4 is 28, right? Now x4 times a, so we have x4 times a x5. So if the bases are the same, we can keep the base and add the exponents. Well, the a is there with nobody, but the x4 and x5 can be combined and be written as x9. Negative and a positive is a negative, and the next two is 4/5 times 40. 4/5 times 40 is going to be 40 divided by 5 is 8 times 4, 32. And then we have x4 times b7. They're not the same base, so we're just going to write them alphabetically, b7 and then the x4. And lastly, negative times a negative is a positive, and 4/5 of 5 is just 4. All the terms are different, so we can't do anything else. Again, this one, combine, distributive property, all that stuff. So first of all, we have the distributive property. Distributive property is going to happen twice here. It's going to happen here. So the 12 here does absolutely nothing. And let's multiply 3/8 a times negative 56 a4 b. Negative times a negative is a positive. 3/8 times 56. Well, 56 divided by 8 is 7. And 7 times 3 is 21. The a here, remember, has an exponent of 1. Can be multiplied with that a fourth. And that's going to give me 8 to the 5th. And don't forget the b. Negative times a negative again is a positive. 3/8 times 16. Well, it's going to be 16 divided by 8 is 2, times 3 is 6. Now that a to the first power and a to the third power gives me a to the fourth, right? Keep the base, add the exponents. Next, negative 12 times 3 is negative 36, and then there are no variables to multiply, so we just write a5 b. Negative 12 times positive a4 is going to be negative 12 a4, and then the minus 50 in the back, right? Like terms, are there any like terms here? Yeah, these two are like terms. I'll write them side by side here. This guy, and I'll write it here, 21 a to the 5th b, and this guy here are like terms. They're same variables raised to the same exact power. And then these two, I'll change colors. This guy and this guy are like terms. And be careful, it's plus 6a4 and minus 12a4. So I put them side by side. Again, remember when we're subtracting and adding, that stays, and we just add or subtract the coefficient, and that's going to give me negative 15. Next one, it's something a4, and we do 6 minus 12, which is negative 6. And finally, positive 12 and minus 50 is just negative 38. So that's it. There's a pattern here. Find the rule, and in this case, let's see, it's first difference is 7. This is what is that? 13, and 44 minus 75 is 19. Well, they're all different, so it's definitely not linear. So let's do the second difference, and that's going to be 6 and 6. So what do we do with that 6? We divide it by 2, and that gives me 3. So 3 is going to be the coefficient of in front of n squared. So what does this sequence look like? A 3n squared sequence. So we're going to replace n with 1, 2, 3, 4, and see what we get. So 1 to the second power is 1, times 3 is 3. 2 to the second power is 4, times 3 is 12. 3 to the second power is 9, times 3 is 27. And 4 to the second power is 16, times 3 is 48. Is it? 4 to the second power is 16, times 3 is 48. Did I make a mistake here? 2 to the second power is 4, times 3 is 12. 1 to the second power. Alright, so now what do? Remember, we gotta subtract this from the original sequence, which is this guy right here. 5 minus 3 is 2. 12 minus 12 is 0. 25 minus 27 is negative 2. Oops, I forgot the last one. What is this number? 4 to the second power 6, that's 48. So 44 minus 48 is negative 4. Okay, so now that we've done that, we're going to, again, we have a new sequence here. 2, 0, negative 2, negative 4. And we're going to find the first difference again. So I know my rule so far is this, 3n squared. There's a little bit more. Find the first difference. From 2 to 0 is negative 2. From 0 to negative 2 is negative 2. And negative 2, right? So they're all the same, so I know it's linear. So in front of that n, we're going to put negative 2. What does a negative 2n sequence look like? Well, negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6, and so forth and so forth. So what adjustments do I have to make to this sequence right here to get 2, to get 0, to get negative 6? What do I do to each of these numbers? Negative 2, negative 4, negative 6, negative 8 to get 2, right? So that's what we're looking for. So one way of doing that is by subtracting. So we can subtract 2 minus negative 2 is actually 2 plus 2. 0 minus negative 4 is actually 0 plus 4, which is 4. Negative 2 minus negative 6 is actually negative 2 plus positive 6. Well, notice that is 4. So the adjustment that we have to make is plus 4, plus 4, plus 4. So our sequence ends up being 3n squared minus 2n. And then what little adjustments that we have to make last? Plus 4. So just to check, let's plug in 1. Let's plug in 1 in here for n, and we should get the number 5. If we plug in 2, we should get 12. If we plug in 4, we should get 44. Let's plug in 4. 3 times 4 to the second power minus 2 times 4 plus 4. 3, 4 to the second power is 16 minus 2 times 4, which is 8, plus 4. 3 times 16 in my book is 48 minus 8 plus 4. 48 minus 8 is 40, and then plus 4 equals 44. So look at that. The third term, right, we substituted, the fourth term, right, is 44. Does it match what it has up here? Yes, it does. Factor the GCF. Okay, so using the greatest common factor, right? So greatest common factor. So actually, you know what? Let me write this again, like this. That's what that is. This is A. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? That's exactly what it is in the expanded form. 3, 4, 5, 6, 7. How many B's? 1, 2, 3, 4. Well, let's take out the greatest common factor between 18, 24, and 30. And I believe that is 6. Right? There's a 6 in 18. There's a 6 in 24. There's a 6 in 30. Is there anything higher? No. So that they all share 6. What variables do they all share in common? Every single one of them has at least 2 A's. There's 2 A's here, there's 2 A's here, and there's 2 A's. They all at least share 2 A's. How many B's do they each share? Well, they each share 3 B's because there's 3 B's here, 3 B's here, 3 B's here. So I can write B to the cube. So that's my factor outside. So again, remember, this times what will give me this. This times what will give me the second. So we have one term, second term, and third term. Right? That's what we're trying to figure out. So let's go and see if we can figure out. 6 times what is 18? Obviously, it's 3. And then a squared b cubed times what is going to give me a squared b cubed? Well, it's just going to be times 3, right? We don't need to add a variable. any variables here. So that's okay. Second term, 6 times what's 24 is 4. And a squared times what would give me a to the 5th? Well, that'd be a to the 3rd. And you can count here. So another hint, we can use this. There's 3 a's left over. And look. B to the 3rd power times what is b to the 6th? And again, here's your answer. B to the 3rd. And that makes sense, right? 6 times what's 30 is times 5. And a to the 2nd times what will give me a to the 7th? Here's your answer, a to the 5th. And b to the 3rd times what will give me b to the 4th? And that's going to be times b. And again, you can do this distributive property now and just multiply this and see if you get the original expression. Same thing here, right? What do they each share? They each share, the greatest common factor is 2. And then do they share any letters? Any variables, I'm sorry? Yeah, they share. Everybody has a y in there. So everybody has a y. So let me cross that y out. Now, 2y times what gives me 10x? Well, it's definitely times 5 and then times x. Plus 2 times what is 26 is 13. And y, and then 2y times what, sorry, would give me 26xz. Well, we have to add the xz. Plus and 2y times what will give me 30. It will be just times 15. Sorry, times 15, right? Because 2 times 15 is 30. And that's going to, let me erase this. That's going to give me 30, right? 2 times 15 is 30, and then the y tags along, and we're good. And then 2 times what is 20 would be 10, and then y times what would give me yz would be just z, because we don't need to do a y here. multiplying polynomial. So it's just a distributive property. We're going to do it here. And then we're going to do it here. Let's do with the 4. 4m times 2m is 8m squared. 4m times 6 is positive 24m. Now we do the 8. Negative 8 times 2m is negative 16m. And negative 8 times positive 6 is plus 48. Can I combine any like terms? Yeah, these two are alike. So 8m squared, and if we combine these two, we get 24 minus 16, which is positive 8m. And then the plus 48. So let's start here. So I'm going to put a 1 in front of the 5 and a 7 to remind you that they each have a denominator of 1. So we get 5, and the negative 3 is being multiplied by every exponent in here, including the denominators, the exponents and denominators. So we get 1 times negative 3 is negative 3. 8 to the 6th power, because it's negative 2 times negative 3. C to the 12th power, positive. At the bottom, 7 to the 1st power, so it's 7 to the negative 3rd. B, negative 5 to negative 3 is positive 15. And C is going to be 12. And then multiplied by a squared, b to negative 3, a7. It's all being multiplied, so I could have just done one whole line. So let's start throwing things up and down. 5 to the negative 3rd goes down. A to the 6th stays up. C to the 12th stays up. A to the 2nd power stays up. B to the negative 3rd goes down. 7 to the negative 3rd goes up. B to the 15th stays down. C to the 12th stays down. And then we have an a to the 7th power here that stays up. Let's see if we can simplify this. Well, in your calculator, you can do 7 to the 3rd power, which is like 243. Am I right? No, 343, sorry. 343. 5 to the 3rd power is 125. Now we have a6, so this is gone, this is gone. a6 and a2 are being multiplied, right? So I can, a6 and a2 can give me a to the 8th power. This is gone, this is gone. C12, there's nothing to do with it. In my denominator, there's an a7. I'm just going to put it alphabetically, so that's gone. B3, B15 can be multiplied, right? Same base, add the exponent. And then C is going to be C12. Now, I'll write it one more time. 343 and 125 can't simplify. Can I simplify my variables? Well, they're 8 to the 8th and 8 to the 7. If I simplify those two, there's 8 A's on the top and 7 A's on the bottom. So if I cross and cross, I'm going to have 1 A left in the numerator. The B's, no, there's nobody to simplify, so I'm going to have 18 B's at the bottom. And C12s and C12, they simplify and go away. So that's my final answer. This one again, I'm going to do the whole thing again, so I'm just going to write it here. It's -2, and again, remember, that has a power of 1, and the 5 have a power of 1. -2 to the -4th power, A to the -20, B to the -12, and C to the -8. The bottom, we're going to have 5 to the -4th, A to the -28, B to the +8, and C to the -12. Let's throw things up and down. -2 to the -4th power is going to be -2 to the 4th power. Down. A to -20 comes down. B to -12 comes down. And C to the -8 comes down. So all these negative exponents are now positive in the denominator. 5 to the -4th power goes up. A to the 28th goes up. B to the 8th stays down. And then C to the -12 goes up. So we're almost there. 5 to the 4th power is, I have no idea, 625. A28, C12. And then -2 to the 4th power. This is -2 times -2 times -2. So 2, 4, 8, 16 positive. A20, I believe that is. B12 and B8, I can combine that and write B20. And C8. Okay. Still not done. 625 over 16. That's A to the 28th power and A to the 20 at the bottom. So these two, right, I'm going to have 8 A's left over, but on the top. B20, no, nothing to cross out. And then C12 and C8, well, I'm going to have 4 C's left over. Where? On the top. So that looks, if I didn't make any mistakes, your answers. Please let me know how you did.